Hello, this is John Garrity. I'm the co-founder and CEO of Tagup. We are a company based out of Boston and New York City, applying machine learning to improve logistics, supply, and maintenance for the U.S. military. This presentation provides a summary of our capabilities and a project brief for our work under NAVAIR topic N193 A01 around readiness and sustainment. Our company's core intellectual property is related to three things. One is data management, so effectively consolidating large varieties of data associated with equipment. This can be sensor measurements, documents, photos, maintenance logs, and many other data types, creating a consolidated data record that can be accessed by authorized users. And from that, draw machine learning models, the training, the validation, the entire pipeline, such that artificial intelligence can be applied against these consolidated data sets to drive a number of different use cases around asset management. And I'll go into some of the specifics later in the presentation, but primarily for this work, again, our SBIR collaboration with the U.S. Marine Corps, this is to drive efficiencies in supply, maintenance, and readiness overall. Our company started, and primary efforts are actually in the private sector, principally in energy. So we work with varied asset types ranging from offshore wind turbines to power transformers to high purity water systems to building HVAC applications. So these methods are very broadly applicable, and happy to discuss further if anyone has interest where these can be applied in specific applications you might have in mind. Again, through this application and presentation, I'll go through the specific use cases that we've developed with the Marine Corps that we are ready to transition to subsequent assets and applications. Our work with the U.S. Marine Corps has been funded under a NAVAIR SBIR Phase 2. The statement of need, the motivation for this work came from a collaboration we had from Ensign, an Ensign fellow, Marine Corps major, worked with us for 6 weeks to specify and help us understand the primary applications of our technology, time to event modeling, anomaly detection, and various other machine learning capabilities to Marine Corps logistics, maintenance, and supply applications. The statement of need is referenced here. Effectively, the current information systems do not possess predictive modeling and simulation tools that are necessary to drive strategic mission critical MAGTF planning efforts. We've delivered on this work over the past 18 months. The scope of funding has revolved around improving scenario planning capabilities using machine learning, developing mission-driven tools to forecast asset availability. And again, the focus has been on the LAV and MTVR vehicle platforms, but these methods are applicable to any TAM, and the extension we're looking toward now is looking at MCBL critical TAMs that can be benefit from these machine learning capabilities as well. So beyond asset availability, we've looked at fleet readiness and unit sustainment needs over a number of different time horizons, arbitrary time horizons. Specifically what parts are required to ensure asset performance during a training exercise or mission, what specific parts, what RNSNs. Additionally, we're looking at what specific assets are best suited for the mission at hand, have the lowest probability of being deadlined during mission duration. The objective, of course, to improve probability of mission success. We've prototyped applications capable of serving this raw data, pulled primarily from GCSS, the clean data, and then the model outputs. And we've again focused on 17 TAMs across the LAV and MTVR assets, about a little over 7,000 assets, serial numbers in particular. The technology key consideration for its design is its ability to be deployed rapidly and deployment that's data source agnostic. So we've looked at a number of different sources beyond just GCSS, but importantly, these are existing data sources. So these technologies don't require the deployment of new sensors or additional hardware. They can work with existing data sources. These can be ERP type transactional sources. They can be financial records, maintenance logs, any number of sources. But importantly, the way the technology is configured is data source agnostic. And finally, our work is built to support the Enable Global Logistics Awareness LOE and provide visibility into readiness performance, maintenance requirements, supply requirements across the Marine Corps. And currently we're looking for a transition partner focused on artificial intelligence and machine learning through an SBIR phase 3. Concretely, during our collaboration, we took data from GCSS and other logistics information systems to create these consolidated records of each serial number. And specifically, that includes preventative and corrective maintenance data, so yes, all service requests effectively, unit activity, and operating status. So unit activity may relate to miles driven, hours on the engine, rounds fired, and operating status, deadline available, op status degraded, and so forth. We've built and delivered automated data cleaning methods that are very generalizable. These include imputation so that we can quantify asset activity. We forecast readiness out 30 days or for arbitrary time periods into the future and can aggregate that by any unit or TAM or equivalently a SKU. We built a mobilization planner, which helps operators optimize EDL specification and provide recommendations around Class 9 block building, which parts are required, what does a loadout look like. And finally, prototype depot level logistics planning, which links material posture to tactical unit activity. All these capabilities are meant to support supply, maintenance, and command requirements, and very broad base. Once the data is consolidated and available, it's available in a very extensible manner. The machine learning capabilities can provide a number of different use cases and address specific needs, whether that's for planning, which parts are required, planning for which assets should be taken on a mission or exercise, and understanding what the readiness posture of a unit or any other organizational unit is out into the future. In terms of the machine learning models, one of the focuses was around improving scenario planning. And so here we looked at asset availability, taking into account all available data for these assets. So this includes their maintenance status, all the activity rates, service request history, the miles and hours data available, failure modes, the defect codes, and then replacement parts, NINs and cost. And all of this information, the entire history, because we've aggregated it in our data management capabilities, we have this all consolidated. We can effectively train, validate, and deploy machine learning models to forecast availability out into the future. These forecasts are handled at an asset level and can be aggregated again by unit, by TAM, or any other measure, so that commanders or maintenance teams or suppliers or any other user can look at readiness out into the future and understand what assets are best suited for a given exercise, which assets need specific attention to ensure that they don't become deadlined during an exercise or mission. There are a number of use cases of these analytics. There are a couple specified here. One is around operational readiness and mobilization planning. So again, this is looking at an asset level, and this can be aggregated up to any number of assets by TAM, by unit, by location. Understanding, given all the available history of each asset individually and in aggregate, what is the readiness looking like out into the future? What is the probability that a given asset is going to be degraded in its performance or deadlined during a mission or exercise? So that's a primary use case. The second is around block building and parts fulfillment. So this is now on the supply side, where supply officers can model and simulate spare parts. And this could be for Class 9 block building as an example, and sustainment costs that are based on actual operational demands and deployment scenarios. So instead of looking at very large averages, you can do a bottoms-up economic analysis, because these forecasts are established at an asset level, and look at the parts requirements for any subset of assets out into the future. Through this work, we've achieved a TRL of 6. The prototype is being tested by the warfighter in a simulated operational environment at this stage. There are a number of key features to review. The first is, again, that these models enable reliable forecast. We validated these predictions through backtesting and demonstrated that they can improve customer wait time, logistics response time, and readiness posture. Importantly, the application technology integrates with the U.S. Marine Corps ecosystem. It's FedRAMP compliant. Technology is prototyped on AWS GovCloud and deployable to any authorized cloud environment, as an example, McBoss. It's cost-effective, scalable, and flexible. Again, we avoid requirement of new sensors or hardware. It's rapidly scalable to new equipment sets, whether that's a multi-million-dollar vehicle down to a radio system. And these are designed to incorporate new data sets. So as additional data becomes available or digitized, it can be rapidly incorporated into the models to improve performance. Finally, the application is designed to be intuitive and actionable. We've built this in collaboration with the warfighter, a number of different units, Marine Corps units, and iterated on the design and data visualization tools so that they require minimal training. There is a very simple learning curve, and again, designed to enable action on any asset that's tracked in GCSS. We've been fortunate to collaborate directly with a number of Marine Corps units. Some examples are listed here. The path to transition and commercialization involves continued collaboration and identifying a data partner to sponsor MDR access. We, again, want to expand this technology to a number of different asset types and other applications within the Department of Defense. And we are open to discussions with anyone who may think they have a good fit for these capabilities. And so thank you for your time and for allowing me to share some of the capabilities that our technology brings to bear and our collaboration with the U.S. Marine Corps. Again, we welcome discussions from all industries about how machine learning can make your equipment safer, more reliable, and more efficient. And I'd encourage anyone to reach out to me directly. My contact information is provided here. Again, this is John Garrity. I'm the co-founder and CEO. My email address is Jon, Jon, @tagup.io. Will is the principal investigator and our CTO, and can also be reached at will@tagup.io. Thanks again for the time, and hope to connect soon.